In question 1, we've got the curve with equation y is 2x cubed minus 4x plus 5, and we need to find the equation of the tangent to the curve at the point P with coordinates 2, 13, and we need to give our answer in the form y is mx plus c, where both m and c are integers to be found. Well, I will start by finding an expression for dy dx. We know that when we differentiate, we multiply by the power and we deduct 1 from the power. So 2x cubed will give me 6x squared. The negative 4x will give me a negative 4, and the 5 vanishes because it is just a constant. I will proceed by evaluating the derivative at the particular point where x is equal to 2. So this is 6 times 2 squared minus 4, which gives an answer of 20. This is the gradient of the tangent at the point P. And I can proceed using y minus y1 is mx minus x1. So we've got y minus 13 is equal to 20 brackets x minus 2. Let's expand to get y minus 13 is 20x minus 40. And therefore we arrive at y is 20x minus 27. In question 2, a Coast Guard station O is monitoring the movements of a small boat. At 10 o'clock we are at the point 4i minus 2j relative to O, and at 12:45 we are at the point negative 3i negative 5j relative to O. Now we are modeling the motion of the boat as that of a particle moving in a straight line at constant speed, and we need to calculate the bearing on which the boat is moving, giving our answer in degrees to 1 decimal place. Well, I will start by labeling as A and B the position of the boat at 10 o'clock and 12:45 respectively, and I will proceed by drawing my axis and plotting the points A and B. So the boat is moving from A to B in the direction indicated by the arrow. So we're trying to find the bearing on which the boat is moving. So the bearing is measured always from the north and turning clockwise. So we're trying to find the size of this angle here. Now to do that, one way is to close the triangle here to form a right angle triangle having sides of 3 and 7 as shown. And I'm trying to find the angle theta here, and then I'm going to use theta to find the angle here, which corresponds to the bearing we're trying to find. So we will start by stating that tan theta is equal to 3 over 7. So theta is going to be shift tan of 3 over 7, which gives an answer of 23.1985 ... Now we know that from the north up to this point exactly it's 270 degrees. So for the bearing, I'm just going to do 270 minus the answer we just obtained. So we're looking at 270 minus the 23.1985 ... which gives an answer of 246.801 ... which correct to 1 decimal place is 246.8 degrees. In part B, we need to calculate the speed of the boat, giving our answer in kilometers per hour. So I will start by finding the distance between A and B. So I'm doing the distance formula. It's x2 minus x1 squared plus y2 minus y1 squared and all square rooted. So -2 minus the -5 squared and all under a square root. This gives an answer of root 58 kilometers. Well, recall that we are modeling the particle as moving with constant speed. So the speed is given by distance over time. We have just calculated the distance to be root of 58 kilometers. And then for the time, well, at 10 o'clock we were at point A. At 12:45 we're at point B. So from 10 o'clock up to 12:45 we've got 2 hours and 45 minutes, or 2 3/4 hours. So I'll divide this by 2 3/4. Let me write the units. I'm gonna get an answer in kilometers per hour. If we plug this on the calculator, get an answer of 2.77 kilometers per hour. In question 3, we need to show all stages of the working, and solutions relying on calculator technology are not acceptable. So we need to be careful here. We need to be showing every single step in every detail. Otherwise, we risk being penalized. So in the first part, we need to solve the equation x root 2 minus root 18 is equal to x, writing our answer in its simplest form in third form. So x root 2 minus root 18 is equal to x. So I will collect the x terms on the left hand side. So we're looking at x root 2 minus x is equal to root 18. I will factor out the x on the left hand side, taking me to x bracket root 2 minus 1. And on the right hand side, I will decompose root 18 as the root of 9 times the root of 2. So we're looking at x times root 2 minus 1 being equal to 3 root 2. And obviously the next step is to say that x is 3 root 2 over root 2 minus 1. I will proceed by rationalizing the denominators. I'll be multiplying by root 2 plus 1 over root 2 plus 1. And let's proceed by expanding and simplifying. So we've got that x is 3 root 2 times root 2. So it's 3 times 2. So let me write this down. 3 times 2 plus 3 root 2. And in the denominator, we've got root 2 times root 2, which is 2, plus root 2 minus root 2 minus 1. So the root 2, the negative root 2 will cancel out. In the denominator, we see that the overall denominator is just 1. And in the numerator, we're looking at 6 plus 3 root 2. In II, we need to solve the equation 4 to the power of 3x minus 2 is equal to 1 over 2 root 2. So the idea is to express everything as a power of 2. So 4 is 2 to the power of 2, and this is raised to the power of 3x minus 2. And on the right hand side, we've got 1 over 2 times 1 times 2 to the half. Now we know that when we've got a power raised to a power, we multiply the indices together. So we're looking at 2 to the 6x minus 4 being 1 over 2 to the 3 over 2, because when I multiply with a common base, we add the indices, and obviously 1 over 2 to the 3 over 2 can be written as 2 to the minus 3 over 2. I can now equate the two powers, so 6x minus 4 is equal to negative 3 over 2. I will multiply throughout by 2 to get 12x minus 8 is equal to negative 3, taking me to 12x is equal to 5, and therefore we conclude that x is 5 over 12. Question 4 is a modeling question. We are told that in 1997, the average CO2 emissions of new cars in the UK was 190 grams per kilometer, and in 2005, the average emission was 169 grams per kilometer. Now, given that capital A is the average CO2 emissions of new cars in the UK n years after 1997, and using a linear model, we need to form an equation linking A with n. So we will treat this as a straight line problem. We know that since we are counting the years after 1997, then for 1997 n is 0, and for 2005 we've got that n is 8. So we are essentially fitting a straight line passing through the point 0, 190 and 8, 169. I will start by finding the gradient, which is given by y2 minus y1 over x2 minus x1. So we're looking at 169 minus 190 over 8 minus 0. This gives an answer of minus 21 over 8. We know that the general equation of a straight line is y is mx plus c. We know that the y-intercept in this case is the 190. We're not talking about y and x, we're talking about a and n. So we end up at a being equal to minus 21 over 8n plus 190. Now in 2016, the average emissions of new cars was 120 grams per kilometer, and we need to comment on the suitability of the model in light of this information. So 2016 is 19 years after 1997, so n is 19. we will substitute this into the model we just obtained in part A. So we're looking at A being equal to minus 21 over 8 times 19 plus 190. If we plug this on the calculator, we get that A is 140.125. And if we compare what we were expecting against what we have actually seen in reality, we can conclude that 140 is a lot greater than 120, and therefore we deem the model not to be suitable. In question 5, we are given the design for a structure used to support a roof. Now the structure consists of 4 steel beams. It's AB, then BD, then BC, and AD. We are told that AB is 12 meters, BC and BD are equal to 7 meters, and the angle BAC is 27 degrees. And we need to work out to 1 decimal place the size of the angle ACB. So this is the angle we're trying to find. I'll call this theta. I will add the lengths that we were given. So there it is, 12, 7, and 7. And I will be using the sine rule. So we've got that sine of 27 over the 7 is equal to sine theta over 12. We will cross multiply to get that 12 sine 27 divided by 7 is equal to sine theta. And if I do shift sine of the left hand side, we arrive at theta is 51.10239 ... Now looking at the diagram we are given here, the angle we are trying to find is obtuse. Actually the 51.10 is the angle D here, so let me write this down. So what's happening is that if we were to apply the sine rule not on triangle ABC but on triangle ABD, we would have seen exactly the same thing, and we would have arrived at theta being 51.10239. So the angle D is the acute angle, the angle ACB is obtuse. This is known as the ambiguous case of the sine rule, and therefore we proceed in saying that ACB is 180 minus the 51.10239 ... which gives me 128.8976, which correct to 1 decimal place is 128.9 degrees. Now the steel beams can only be bought in whole meter lengths, and we need to determine the minimum length of steel that needs to be bought to make the complete structure. So looking at the diagram, we need to find the total length needed. We already have 3 of the 4 lengths, so the whole objective is to find the length of AD. I will start by finding the size of the angle ABD, and I will then proceed with the cosine rule to find the length of AD. So to proceed and find ABD, I will use the fact that angles in a triangle add up to 180 degrees. So I will be deducting the 51.10 and the 27 from 180. So we're looking at 180 minus the 27 plus the 51.10239. This gives an answer of 101.8976. And I will proceed with the cosine rule. So we've got that AD squared is equal to 12 squared plus 7 squared minus 2 times 12 times 7 times the cosine of the angle we just found, so 101.8976 ... This gives an answer of 227.635 ... And if I take the square root of this, I get 15.087. And since the steel beams can only be bought in whole meter lengths, we need to buy 16 meters to cover the distance AD, and therefore the total length of steel needed will be found by doing 12 plus 7 plus 7 plus 16, which gives an answer of 42 meters. In 6a, we are asked to find the first 4 terms in ascending powers of x in the binomial expansion of 1 plus kx raised to the power of 10, where k is a non-zero constant, and we need to write each coefficient in a simplified form. So we've got 1 plus kx to the power of 10. We start with 1 raised to the power of 10 plus 10, choose 1 to the power of 9 times kx, plus 10, choose 2, 1 to the power of 8 kx, all raised to the power of 2, plus 10, choose 3, 1 to the power of 7 kx raised to the power of 3, plus ... Notice that the sum of the powers is always the original power, and each time we drop the power by 1 and we increase the power on the kx term. Now if we plug this on the calculator, we get 1 plus 10kx plus 45k squared x squared plus 120k cubed x cubed plus ... Now, given that in the expansion of 1 plus kx to the 10, the coefficient of x cubed is 3 times the coefficient of x, we need to determine the possible values of k. So the coefficient of x cubed is the 120k cubed, and we are told that this is equal to 3 times the coefficient of x, which is 10k. So this is equal to 3 times 10k. So we're looking at 120k cubed is equal to 30k. I will proceed by dividing both sides by 30 to get 4k cubed is equal to k. And I'll collect everything on the left hand side. So we've got 4k to the power of 3 minus k is equal to 0. I will factor out the k. So I get k brackets 4k squared minus 1 is equal to 0. And this further factorizes using the difference of two squares into k brackets 2k minus 1 times 2k plus 1 being equal to 0. So we are looking at k is equal to 0, or 2k minus 1 is equal to 0, or 2k plus 1 is equal to 0. Now the solution of k is 0 is rejected, it's not valid, and this is simply because the question itself says that k is a non-zero constant. So I need to say here, since k is not equal to 0. Now for 2k minus 1 is 0, we get that 2k is 1, and therefore k is 1 over 2. And for 2k plus 1 is 0, we get that 2k is negative 1, and therefore k is minus a half. So we've got two possible values for k, a half and minus a half. In question 7, we are told that k is a positive constant, and this integral here evaluates to 4, and we need to show that this leads to 3k plus 5 root k minus 12 is 0. So starting with the given integral, I will first write it in index form. So we're looking at the integral from 1 up to k of 5 over 2x to the minus a half plus 3 dx. We proceed by increasing the power by 1, dividing by the new power. So we've got 5 over 2 x to the 1 over 2 divided by 1 over 2 plus 3x, and the limits are 1 and k. Now obviously we simplify the 2 here, so we are looking at 5 root x plus 3x from 1 up to k. I will substitute the upper limit, and this will give me 5 root k plus 3k, and then we will substitute the lower limit, so we've got 5 root 1 plus 3 times 1. Let's proceed to get 5 root k plus 3k minus 8, and we know that this gives an answer of 4. So if we collect everything on the left hand side, we get that 3k plus 5 root k minus 12 is 0 as required. In part B, we are asked to hence use algebra to find any values of k satisfying this equation here. So essentially we need to solve the equation we just found in part A, and to do that I will start by saying let w be root k. So we are looking at what is known as a disguised quadratic in root k. So we know that if we set w to be root k, this means that w is surely greater than or equal to 0, and w squared is equal to k. So we're looking at 3w squared plus 5w minus 12 is equal to 0, which factorizes into 3w minus 4 times w plus 3 being equal to 0. So we've got 3w minus 4 is 0, or alternatively w plus 3 is equal to 0. So we've got 3w is 4, which means that w is 4 over 3, and therefore root k is 4 over 3. I will proceed by squaring everything to get that k is 4 over 3 raised to the power of 2, which gives an answer of 16 over 9, while for w plus 3 being equal to 0, we get that w is negative 3, and we stop there. We reject it because we know that w is greater than or equal to 0, so I'm going to say here reject, it's not valid, and therefore all in all we've got only one solution, that k is 16 over 9. In question 8, the temperature theta degrees Celsius of a cup of tea t minutes after it was placed on a table in a room is modeled by this exponential equation here. We need to find, according to the model, the temperature of the cup of tea when it was first placed on the table. So essentially we just need to put t is 0, so when t is equal to 0, we get that theta is 18 plus 65 e to the power of 0. Well, we know that e to the power of 0 is 1, and 18 plus 65 is 83, and we need to include the units, so we're looking at 83 degrees Celsius. In part B, we need to find the value of t to one decimal place when the temperature of the cup of the tea was 35 degrees Celsius. So this time we've got theta being 35, so when theta is 35, we've got that 35 is 18 plus 65 e to the minus t over 8. This leads to 17 being 65 e to the minus t over 8. We will divide both sides by 65, arriving at 17 over 65 is equal to e to the minus t over 8. I will take a ln of both sides, so we've got a ln of 17 over 65 being equal to minus t over 8, and I will multiply by 8 to get 8 ln of 17 over 65 being negative t. I'll multiply both sides by negative 1, arriving at negative 8 ln of 17 over 65 is equal to t, which gives an answer for t of 10.7 minutes, which is the time taken for the temperature to drop to 35 degrees Celsius. In C, we need to explain why, according to this model, the temperature of the cup of tea cannot fall to 15 degrees Celsius. Well, this is the equation of the model. We know that as t grows larger and larger, so as t tends to infinity, the exponential term will go to 0 because the exponent is negative. So we've got e to the minus t over 8 tending to 0, and therefore we can see that theta tends to 18. We cannot see the limit of e to the minus t over 8 as t goes to infinity. We cannot follow this process here. We can just simulate this on the calculator. I'm going to put a big number on my answer key, and then I'm going to do 18 plus 65 e to the minus ans over 8. So essentially I'm substituting a really big value for t just to see what happens to theta. We see that it tends to 18, and therefore we can see that according to the model, the temperature can never fall to 18 degrees Celsius, and hence it cannot fall to 15 degrees Celsius. Now the temperature mu degrees Celsius of a second cup of tea t minutes after being placed on a table is modeled through this equation here. Mu is capital A plus capital B e to the minus t over 8. We're given a sketch of the graph, and we are being told that we pass to the point 094 and 850. Now we need to use the equation of this model and the information provided here to find an equation for the asymptote. It's the horizontal line L here. So I will start by stating once more that as t tends to infinity, the exponential term here tends to 0, and therefore mu is A is going to be the equation of the horizontal asymptote. I will then use the fact that when t is equal to 0, we've got that mu is equal to 94, and this means that we're looking at 94 being equal to A plus b e to the power of 0, which of course simplifies to 94 being equal to a plus b. We also have that when t is equal to 8, we've got that mu is equal to 50, and therefore this means that 50 is equal to a plus b e to the minus 8 over 8. So we've got that 50 is a plus b e to the minus 1. All in all, we are working with simultaneous equations in A and B. I'm going to label the 94 is A plus B as 1, and the 50 being A plus B e to the minus 1 as 2. And I would be deducting 1 from the other, so I'll be doing 1 minus 2. So 94 minus 50 is 44. The A will cancel out, and we've got on the right hand side B minus b e to the minus 1. So we're looking at 44 being equal to b brackets 1 minus e to the minus 1, and therefore 44 over 1 minus e to the minus 1 is equal to b. I can plug this on the calculator. We get that b turns out to be 69.6069 ... and using the fact that a plus b is equal to 94, we get that 94 is equal to a plus 69.6069, and therefore get that 24.393 ... is the value of a, and we conclude that the equation of the horizontal asymptote is mu is 24.4. In question 9, we're given part of the curve with equation y is 3 cos x. Now the point P with coordinates C, D is a minimum point on the curve, with C being the smallest negative value of x at which a minimum occurs. And we need to state the value of C and the value of D. Well, I will start by sketching on this diagram the graph of y is cos x. We are cutting the x-axis at 90, 270, negative 90 and negative 270. We are attaining maximum at negative 360, 0 and 360, and minima at minus 180 and 180. Now the 3 here means that we are stretching along the vertical with a scale factor of 3, so we are multiplying the y values by 3, and therefore the point minus 180 negative 1 will see its y coordinate multiplied by 3, taking us to minus 180, negative 3, and therefore we conclude that C is negative 180 and D is minus 3. In part B, we need to state the coordinates of the point to which P is mapped by the following transformation. So we are starting from y is 3 cos x, and we're now considering 3 cos of x over 4. Now that x over 4 means that we are multiplying x by 4, while for y is 3 cos x minus 36. The minus 36 means that we are translating 36 to the right, so we are adding 36 to x. So the original point was at minus 180, negative 3. If I multiply x by 4, we arrive at minus 720, negative 3. While for the 3 cos x minus 36, we arrive at minus 144, negative 3, because we have added 36 to the value of x. In part C, we are asked to solve the given trigonometric equation for theta between 450 and 720, giving our solution to 1 decimal place. So we've got 3 cos theta is 8 tan theta. The first thing to do is write tan theta as sine theta over cos theta, and then I will proceed by cross multiplying, arriving at 3 cos squared theta being equal to 8 sine theta. Now we know that sine squared plus cos squared is 1, so we've got 3 brackets 1 minus sine squared theta being equal to 8 sine theta, and we expand the left hand side to get 3 minus 3 sine squared theta being equal to 8 sine theta. I will be collecting everything on the right hand side, taking me to 0 being equal to 3 sine squared theta plus 8 sine theta minus 3. So we are dealing with a quadratic in sine theta, which I can factorize into 3 sine theta minus 1 times sine theta plus 3. So we've got 3 sine theta minus 1 being equal to 0, or alternatively we've got that sine theta plus 3 is equal to 0. Now from this second equation, we get that sine theta is negative 3, which is rejected. It's not valid because we know that sine theta takes values between minus 1 and 1. So for 3 sine theta minus 1 is 0, we get that 3 sine theta is equal to 1, and therefore sine theta is 1 over 3. I will proceed by finding the principal value, which is the shift sign of the 1 over 3. So I'm going to go on my calculator, I press shift sign 1 over 3. This gives an answer of 19.471 ... I'm going to store this on A, so the A key now holds the exact value, so 19.471 and the full accuracy. And we know that when we are dealing with trigonometric equations involving sine, then the solutions are given by theta being the PV, which is A plus 360k, or theta being 180 minus the PV plus 360k. And therefore I can go on my calculator, I press menu, it's option 9. My f of x will be A plus 360x, and my g of x will be 180 minus the A plus the 360x. I will start at negative 2. I will go up to 5. I'm stepping every one, so I'm automating the whole process of generating solutions. Remember, theta is between 450 and 720. So if we go through this table here, all of these are solutions. The only solution which is between 450 and 720 is 520.528 ... which correct to one decimal place is 520.5 degrees. In question 10, we are given g of x here, a polynomial of degree 3, and we need to use the factor theorem to show that g of x is divisible by x minus 5. Well, we know that the factor theorem states that if x minus alpha is a factor, then f of alpha is 0. So I'll be evaluating g of 5. So g of 5 is equal to 2 times 5 to the power of 3 plus 5 squared minus 41 times 5 minus 70, which gives me 250 plus 25 minus 205 minus 70, which gives an answer of 0. And therefore we conclude that x minus 5 is a factor, which simply means that g of x is divisible by x minus 5. In part B, we are asked to write g of x as a product of 3 linear factors. So now that we know that it is divisible by x minus 5, I will proceed with the long division. So in long division, we're trying to match the highest order term found on the left-hand side. So x will be multiplied by 2x squared, giving me 2x cubed minus 10x squared, and we deduct. We get 11x squared minus 41x minus 70. So this time I will multiply by 11x to get 11x squared minus 55x. I deduct once more and I get 14x minus 70. So I will multiply now by 14, giving me 14x minus 70. And upon deducting, I get a remainder of 0 as expected. Therefore, we conclude that g of x can be written as a product of x minus 5 and 2x squared plus 11x plus 14, which further factorizes into x minus 5 times 2x plus 7 times x plus 2. Now the finite region R is bounded by the curve with equation y is g of x and the x-axis and lies below the x-axis. and we need to use algebraic integration to find the exact value of the area of R. We've got the factorized form for g of x. We know it's a cubic with the coefficient of x cubed being positive, so the shape is something like this. I will start by finding the cuts on the x-axis. So if we set g of x to be 0, we arrive at x minus 5 being 0, 2x plus 7 being 0, or x plus 2 being 0. So we've got cuts at x is 5, 2x is negative 7, which means that x is negative 7 over 2, and x is negative 2. We also know that when we cut the y-axis, x is 0, so g of 0 turns out to be negative 70, and therefore we can proceed in sketching the graph to see exactly the region we're trying to find. We've got the axis here. This is the sketch of the curve, and we're trying to find the region shaded here. It's the region R. I'll be using integration, so we will be integrating from negative 2 up to 5. The expanded form of g of x is 2x cubed plus x squared minus 41x minus 70. Now in integration, we are increasing the power by 1. We are dividing by the new power. So we're looking at 2x to the power of 4 over 4 plus x to the power of 3 over 3 minus 41x squared over 2 minus 70x, and the limits are negative 2 and 5. I will start by simplifying the 2 with the 4, leaving me with the 2 in the denominator, and I will substitute the upper limit of 5. So we've got 5 raised to the power of 4 over 2 plus 5 raised to the power of 3 over 3 minus 41 times 5 squared divided by 2 minus 70 times 5, and then I will substitute the lower limit. So we've got negative 2 raised to the power of 4 over 2 plus negative 2 raised to the power of 3 over 3 minus 41 times negative 2 raised to the power of 2 over 2 minus 70 times the negative 2. Now if we plug this on the calculator, we get an answer of negative 1715 over 3. Now we shouldn't be surprised that we got a negative answer. The negative indicates that we're lying below the x-axis. However, the area as a concept is always positive, and therefore we conclude that R is equal to 1750 over 3 squared units. In 11i, we've got a circle C1 with this equation here. The line L is the tangent to the circle at the point P, negative 5, 7. And we need to determine an equation for this line L in the form ax plus by plus c is 0, where a, b, and c are integers to be found. Well, we know that the circle centered at alpha beta with radius r has equation x minus alpha squared plus y minus beta squared is r squared. So I will be completing the square here to determine the center of this circle. So we're looking at x plus 9 squared minus 9 squared plus y minus 1 squared minus 1 squared plus 30 is equal to 0. So we've got x plus 9 squared minus 81 plus y minus 1 squared minus 1 plus 30 is equal to 0. And therefore we've got that x plus 9 squared plus y minus 1 squared minus 52 is 0, which means that x plus 9 squared plus y minus 1 squared is equal to 52. Now that we've got the equation of the circle in the standard form, we can simply state that the center has coordinates negative 9, 1, and therefore we can quickly sketch a circle centered at negative 9, 1. We've got the point P with coordinates negative 5, 7. We're trying to determine the equation of the tangent, which is the line here just touching on point P. And if we join the center with the point P, if we draw the radius, we know that this angle here should be a 90-degree angle. So I will start by finding the gradient of the radius using rise over run. So we've got 7 minus 1 over negative 5 minus the negative 9, which gives an answer of 3 over 2. And therefore, we know that the gradient of the tangent will be found by flipping and changing the sign of the gradient of the radius. So it's negative 2 over 3. Now we've got the gradient. We've got a point through which we pass. So we're going to use y minus y1 is mx minus x1. So we are looking at y minus 7 being equal to negative 2 over 3 times x minus the negative 5. I will cross multiply to get 3 brackets y minus 7 is equal to negative 2 times x plus 5. Let's expand the brackets to get 3y minus 21 is negative 2x minus 10, taking me to 3y plus 2x minus 11 is equal to 0. In II, we've got a different circle C2 given here in terms of K, which is a constant. Now we are told that C2 lies entirely in the fourth quadrant, and we need to find the range of possible values for K. So once more, I will start by completing the square. We've got x minus 4 squared minus 4 squared plus y plus 6 squared minus 6 squared plus k is equal to 0, which means that x minus 4 squared minus 16 plus y plus 6 squared minus 36 plus k is equal to 0, and therefore x minus 4 squared plus y plus 6 squared minus 52 plus k is equal to 0, which leads to x minus 4 squared plus y plus 6 squared is equal to 52 minus k. Now that I've got the equation in the standard form, I can conclude that the center of this circle has coordinates 4, negative 6, and the radius r is going to be the square root of 52 minus k. And we know that this circle is lying entirely within the fourth quadrant, so if I was to sketch this, it would be something like this. We know that the center is at 4, negative 6, which means we are 4 units from the y-axis and 6 units below the x-axis. So we need the radius to be less than these distances to ensure that we are entirely within the fourth quadrant. So I'm going to say that we need the radius, which was found to be the root of 52 minus k, to be less than 4. And also we need this radius of 52 minus k square rooted to be less than 6. So if I square both sides, I get 52 minus k being less than 16, which means we need 36 to be less than k. Whereas for the second inequality, we've got 52 minus k being less than 36, and therefore we get that 16 is less than k. Now I'm tempted in saying that both of these inequalities are satisfied for k being greater than 36, which will be my final answer. However, we need to be careful here. R needs to be well defined, so 52 minus k cannot be negative, and r is a distance, it's a radius, so it must be positive. So this means that we also need the expression within the square root to be positive, so we need 52 minus k to be greater than 0, which means that we need 52 to be greater than k. I can therefore illustrate everything on a number line for k. We had k being greater than 16, there it is. We had k being greater than 36, there it is. And we have also arrived at k being less than 52. So we want all three of these inequalities to be satisfied. They are obviously satisfied between 36 and 52, which I have highlighted here in red. And therefore my final answer is that 36 is less than k, which is less than 52. In question 12, we've got an agency monitoring the number of views of an online advert. The equation is given here. We are modeling the total number of views, capital V, T days after we went live. Now we need to show that this means that V is AB to the T, where A and B are constants to be found, giving the value of A to the nearest whole number and the value of B to 3 significant figures. Well, let's start with the equation. We are given V is A, B to the T. It makes sense to take logs of both sides. So log of V base 10 is equal to log of A, B to the T base 10. So we're looking at log v base 10 being equal to log of a base 10 plus log of b to the t base 10. I've used the product rule of logarithms, which says that the log of the product is the sum of the logs. Now this can be further simplified into log v base 10 being equal to log a base 10 plus t log of b base 10. And I can now compare with the equation I was given that log v is 0.072t plus 2.379. So if we compare this, we see that the 0.072 is the coefficient of t, so it's the log of b. And then we've got the 2.379 being the log of a base 10. So we are looking at log of b base 10 being equal to 0.072 and the log of a base 10 being 2.379. This means that b is equal to 10 to the power of 0.072, which gives an answer of 1.18032 ... which correct to three significant figures is 1.18. And we also have a equal to 10 to the 2.379, which gives an answer of 239.3315, which correct to the nearest integer is 239. And therefore we conclude that capital V is 239 times 1.18 raised to the power of t. Now in part B, we need to interpret with reference to the model the value of AB. So we notice that when t is equal to 1, we've got V is AB raised to the power of 1, which is of course AB. So in our case, we are looking at 239 times 1.18, which gives an answer of 282.487 ... which simply means that one day after we went live, the total number of views was 282. In C, we need to use this model to calculate the total number of views in the first 20 days after we went live, giving our answer correct to two significant figures. This is the equation that was given from the question itself. I'm going to use this one. I'm not going to use my equation because I know for sure that this is correct. We need to substitute t is 20. So when t is equal to 20, we get log of v base 10 is 0.072 times 20 plus 2.379, which means that log of v base 10 is equal to 3.819, and therefore v is 10 to the 3.819, which gives an answer of 6,591.7389, which correct to two significant figures is 6,600 views. In 13a, we need to prove that for all positive values of a and b, 4a over b plus b over a is greater than or equal to 4. Now we need to construct a proof here. I don't know where to start, so I will start from exactly where I need to end up at. This is not a solid proof yet. I'm going to call this my jottings, my rough work. So starting with what we are given, we've got 4a over b plus b over a being greater than or equal to 4. Now since a and b are positive, I can multiply throughout by ab to get rid of the denominators. So we're looking at 4a squared plus b squared being greater than or equal to 4ab. And I'm going to mention here that this is valid since both a and b are positive. Now we'll collect everything on the left-hand side. We get 4a squared minus 4ab plus b squared being greater than or equal to 0. And I should be able to recognize the left-hand side as being a perfect square. It's 2a minus b all squared being greater than or equal to 0. Well, we know that this is always the case because anything squared cannot give me a negative result. So this is the starting point I was after. So I can now go and present my solid mathematical proof. So I'm going to call this proof. We start from 2a minus b all squared being greater than or equal to 0 for all values of a and b. I will expand this. 4a squared minus 4ab plus b squared is greater than or equal to 0. So what I'm doing here is I'm going in reverse through my jottings in order to arrive at exactly what I need to prove to be true. So the next thing to do is write that 4a squared plus b squared is greater than or equal to 4ab. I will now divide throughout by ab, so 4a squared over ab plus b squared over ab is greater than or equal to 4. And I need to mention that this is true and I don't have to worry about reversing the inequality direction because both a and b are positive. And so we end up at 4a over b plus b over a being greater than or equal to 4 as required. Now in part B we need to prove by counterexample that this is not true for all values of a and b. Now it's enough to provide numerical values for a and b that will show that this statement does not hold true for all values of a and b. So I'm going to pick a negative value for a and a positive value for b. So I'm going to say suppose a is negative 1 and b is equal to 1. Then what we can see is that 4a over b plus b over a turns out to be 4 times negative 1 over 1 plus 1 over negative 1, which gives an answer of negative 4 minus 1, which is negative 5, which is obviously less than 4. And therefore we conclude that the statement is not true for all values of a and b. In question 14, we've got a curve with the equation y is g of x, and it is given that g of x is a cubic expression in which the coefficient of x cubed is equal to the coefficient of x. In addition, the curve passes through the origin and has a stationary point at 2, 9, and we need to find g of x. So I will start by proposing a general form for g of x. So I'm going to say that g of x is alpha x cubed plus beta x squared plus gamma x plus delta. So this is the expression for a general cubic. Well, we have been told that the coefficient of x cubed is equal to the coefficient of x. So this means that alpha is equal to gamma. And we also know that we pass through the origin. This means that g of 0 is 0, which simply means that 0 is the value of delta. So I can update the original form here with this additional information. So we're looking at g of x is equal to alpha x cubed plus beta x squared plus alpha x. I will then use the fact that we've got a stationary point at 2, 9. So I will find an expression for dy dx, or g dash of x in this case. So g dash of x is 3 alpha x squared plus 2 beta x plus alpha. We know that stationary points satisfy that the derivative at the particular point is 0. This means that g dash of 2 is equal to 0, which means that 0 is 3 alpha times 2 squared plus 2 beta times 2 plus alpha. So we're looking at 0 is 12 alpha plus 4 beta plus alpha, and therefore 0 is 13 alpha plus 4 beta, which means that negative 13 alpha is equal to 4 beta. And in addition, we know that the point with coordinates 2, 9 lies on the curve. So in other words, g of 2 is equal to 9, which means that 9 is equal to alpha times 2 to the power of 3 plus beta times 2 to the power of 2 plus 2 alpha. So we are looking at 9 is equal to 8 alpha plus 4 beta plus 2 alpha. So we've got 9 is equal to 10 alpha plus 4 beta, and therefore 9 minus 10 alpha is equal to 4 beta. Now I've got two equations involving alpha and beta. I've got 4 beta in terms of alpha in both cases, so I can simply equate the negative 13 alpha with the 9 minus 10 alpha, which takes me to negative 9 being equal to 3 alpha, and therefore alpha is negative 3. And I will proceed in finding beta. So we've got minus 13 times the alpha, which is negative 3, being equal to 4 beta, So 39 is 4 vita, which means that 39 over 4 is the value of vita. So all I'm missing is to write down the expression for g of x. So g of x is minus 3x cubed plus 39 over 4x squared minus 3x. In part B, we need to prove that the stationary point at 2, 9 turns out to be a maximum. So this is the expression we have for g of x. I will find g dash of x now that I've got all the coefficients of the different terms. So we multiply by the power, we deduct 1 from the power. So it's going to be minus 3 times 3x squared plus 39 over 4 times 2x minus 3. Now the 2 with the 4 simplify, leaving me with the 2 in the denominator. So we're looking at g dash of x being negative 9x squared plus 39 over 2x minus 3. I will proceed in finding the second derivative. So g dash dash of x, which is going to be minus 9 times 2x plus 39 over 2, which of course giving me minus 18x plus 39 over 2, and I will now evaluate the second derivative when x is 2. So g dash dash of 2 is equal to negative 18 times 2 plus 39 over 2. This gives an answer of negative 33 over 2, which is less than 0. And we know that when the second derivative gives me a negative result at a stationary point, then we conclude that this is a maximum point. We need to show explicitly the comparison with 0 to qualify for full marks. If this was giving me a positive answer, I would have concluded it's a minimum. And if this gives an answer which is equal to 0, then the second derivative test would have been inconclusive.